Well, good morning, everybody. My name's John O'Donoghue from Power Oasis. Power Oasis does power management and control of cell sites. And what we do is we decrease the energy consumption at the cell site by 50%. And also we reduce the network OPEX by 30%. And how we do it is by doing site control and linking into a software management platform that enables the operator to manage over 1,000 sites at the NOC. Power Oasis is also a member of the GSMA Energy Efficiency Program, and what I'm going to present today is some of the best practices around cell site energy efficiency. So there's a lot going on wireless. There's nearly 7 billion subscribers because many subscribers have a cell phone, a smartphone, an iPad, a tablet, so multiple connections. Network operators are rolling out LTE platforms, upgrading the networks. There's an explosion of data, more and more data. For the operator, more and more investment. There's 5 million towers worldwide. Machine to machine is the next big thing in communicating. So the operator is challenged today about how does he deliver the customer experience with all these drivers and technology, and how does he drive his ROI and profitability. And sitting in the middle of this is a huge opportunity in getting the network energy costs down, and how can he drive his energy efficiency. So let's look at the benchmark data. There's 126 terawatts of energy consumed annually in all the network operators, and the energy cost is $20 billion. There's 76 megatons of CO2 emitted. And what we see, it's an upward trend, and if we take the consumption per connection, it's declining because there's more and more connections. Or unit of traffic, it's declining. But the base energy consumption continues to go up, and as we all know, the cost of energy continues to go up. If we look at the regions, we see the US is a high energy consumer. So that gives us the opportunity because many of the networks are not optimized for energy efficiency. The other dynamic is in Africa, high energy consumption because there isn't grid and they use diesel generators to power multiple sites. Now, if we break it down by operators, the GSMA benchmarked 20 operators across the world with a wide spread of results. So there's a 10x difference between the best operator and the worst operator. But what it means to us is if you were to target getting average performance and move from the bottom quartile to average performance, you would save 25% of your energy costs. If you wanted to move from bottom quartile to industry best practice, you'd save 40% of your energy cost. So there's a tremendous opportunity to make real network savings. So how easy is it? How do you do it? What's the best practice? Well, I've picked out a case study. It's a European operator. It operates in 9 countries, 3 in Europe, 3 in Eastern Europe, and 3 in Asia. So a good spread of geographies, both developed, developing world. It has about 90,000 cell sites spread in the 9 countries. And before they embarked on an energy efficiency program, they were spending $600 million annually on their energy costs. They've implemented the energy program and they're on track to lower their cost to $380 million. They've had to invest in new technology, but the payback is 19 months. And what they found was that 80% of their energy costs was in the network. Buildings and transport was about 20%, And yet, in the past, there's been tremendous investment in data centers, buildings, and energy efficiency. And the network has largely been left with an architecture that's 20 or 30 years old from an energy perspective. So how do we get an energy efficiency strategy? What are the pillars? Well, the first thing you could do is you could implement site monitoring and control to understand what's going on site. Monitor the equipment, how much energy, where are the alarms coming from, what products are not functioning, and just benchmark your site. And that gives you the template to develop a site efficiency strategy. And one of there's three core pillars in a energy efficiency program. One is moving to outdoor sites rather than indoor sites, because indoor sites consume a lot of energy and cooling. Implement a cooling strategy where you use free air cooling. Modern radio equipment can operate to 40, 50 degrees centigrade, so you don't need to cool the room to 20 degrees. Implement DC on site rather than AC. Again, lighting, all the ancillary equipment on DC gives about a 20% gain. And then zone and do the site optimized towards cooling and consumption. On implementing new technology, implementing modern base stations, they're about 2 times more efficient than previous generations. Implementing remote radio heads. The other thing is dynamic matching of radio resources. So what we do today is we blast out the same amount of power on site 24 hours a day. So at 3 o'clock in the morning, the whole square is lit up and there's nobody there. So dynamic changing of radio power can drive the consumption. Today's batteries can also operate at high temperature ranges, so you don't need to implement a cooling. Efficient rectifiers. Modern rectifiers operate at about a 96% efficiency, again driving tremendous optimization around energy consumption. And finally, power sources. Many operators have standby generators, and you can implement a hybrid battery where you can run the site off the battery and then charge up the battery with the generator. Again, getting economies and driving the site more efficiently. Across the world, the smart grid has been implemented. So what we can do is we can look at the grid tariffing and at peak hours come off the grid and power the site from the batteries, implementing energy arbitrage so the site never runs at peak energy consumption tariffs, and you gain immediate benefits. And then implementing renewables, and in many states there's tax and grant incentives for implementing renewables. So again, that drives the payback. So we got 3 core elements of an efficiency strategy, but they're all linked together on the site control and the monitoring system. And how that looks in practice is, at the center of site control, there's a Power Oasis Smart Hub controller, which is monitoring and controlling the power sources on site. And then it's taking the data and sending it up to the network management system. So remotely you can control and see what's going on site and optimize and change in relation to alarms and problems. How it looks at the network management center, you very quickly have a holistic view of the network. So all the sites in green, they're working well. And then you can double click on the red sites and see what the problem is. What's the power profile? Where am I getting alarms? Can I reconfigure? And again, you're avoiding sending engineers to site and reducing your OPEX cost. But if you have to send an engineer to site, He knows what the problem is. He comes prepared with the right toolkit and the right parts to fix the problem. So this gives the operator total visibility of his network and a different level of control and management capability. Taking the next step forward, how do I look at the network going forward? How do I profile it? So the PowerOasis platform provides trend reporting and analysis, so you can compare the performance of regions, the performance of subcontractors. You can look at where there's a trend to a problem, so you can anticipate where the problems are and what goes wrong, and how do you stop problems taking sites down. So this becomes a powerful tool to get the next level of knowledge and action in the network. So in summary, there's big savings to be had in energy efficiency on sites. 30, 40, 50% energy savings is available. By implementing an energy strategy, you stop running your network blind. You got the knowledge on the network to take action. And also, as you implement best practice at your cell site, you make the site more resilient, you avoid problems, and it also enables you integrate future technologies so you can avail of them in the next 3 or 5 years. So in conclusion, going forward, the biggest impact an operator can have is implementing a total energy efficiency strategy. Okay, thank you.